Okay, so this is for the non-calculated part of the midterm review. So we're actually going to start with question number 10 because that helps with questions 7, 8, and 9. So I'm going to scroll down to question 10 and do this one first. So it says write the expression that's equivalent to this. So we need to multiply all this together. So there's a couple different ways you can do it. I'm going to do it what I think is the easiest way. So I'm going to distribute the 3 to this. That will give me 6x plus 9. And now I need to multiply my answer, which is these two, my answer times x minus 4. And that means I need to do the box. So I'm going to do the box underneath and do x minus 4. So that's going to be 6x squared plus 9x minus 24x minus 36. So then this answer, when I combine like terms, I'm going to get 6x squared. I'm going to put these two together because these are like terms. So 9x minus 24x is negative 15x. And then I'm going to put my last one, the negative 36 here. All right, so now we've multiplied everything together and now we need to multiply the last one. So this one we haven't used yet. So we need to multiply our answer from the previous ones by x plus 1, which means I need to make 3 columns. And then I'm just multiplying. So 6x squared times x is 6x to the third. This is negative 15x squared. This is negative 36x. And then I'm just rewriting these because they're all just multiplied by 1. So 6x squared minus 15x and minus 36. And now we need to start with our first degree, our highest degree. And then we're going to combine like terms. So this is 6x minus 15x squared. So that's going to be negative 9x squared.
All right.
And then a negative 15x minus 36x,
0, 0.
which is negative 51x.
7, 6, 1.
And then minus 36.
Yes, sir.
So this is our answer. All right, so using this concept is how we're going to do number 9, but we don't need to know everything for number 9. So it's actually easier to do 8 and 9 first and then graph it. So for stating the end behavior, that's when we needed to do look back at our notes and remember how to do the end behavior. So here's how we did end behavior. So remember, we have to look at the leading coefficient when it's in standard form, and we have to look at the degree, which is the highest exponent. So when we do that, the leading coefficient tells us if it's positive or negative, and the degree is telling us if it's even or odd. And then we just look at the chart. So we look back at the answer or the question. We only need the leading coefficient and the degree. So when I multiply these, I'm going to do the same thing I just did down there. I'm going to multiply this times this and this times this. But I only really care about the leading coefficient. So I'm going to multiply the negative 2 times the 2 times the x times the x. Now this means that there's 2 of these. So I'm going to write another x plus 1 times the x. So negative 2 times 2x times x for this one times another x for that one times another x for that one. So that will be negative 2 times 2 is negative 4. And then there's 1, 2, 3, 4 x's. So x to the 4th. So that tells me my leading coefficient is negative and my degree is 4. So when I go back to my chart, my leading coefficient is negative, which is here. And my degree is 4, which is even. So it's going to be a negative, negative ending. So we can go back here. And that tells me my ending behavior, which is number 9, is negative, negative. Then this is enable the x and y intercepts. So for the x-intercepts, I'm just going to set each of the parentheses equal to 0. So I'm going to do 2x minus 3 equals 0. I'm going to solve that. So add 3 on both sides. 2x equals 3. I divide by 2. And x equals 3/2 or 1.5. And since I'm going to graph it, I'm going to leave it as 1.5 and graph it over here. Then I'm going to do the next one. X plus 3, set that equal to 0. We've done this so many times, we should know this is negative 3. So then I'm going to graph that one. And then the last one, the x plus 1. Now I have this twice, so this is going to come back when we're graphing it. But I only need to put 1 dot here, x equals negative 1. but I do have that twice, so I'm gonna put this as -1. I'm gonna draw like a second dot here to remind me that's where I have the squared. So remember, the problem started off with x plus 1 squared, so there's really 2 of those. So then when I do the end behavior, it's gonna start, I'm still. So, I'm gonna graph it, it's gonna start negative, negative, so negative, negative. And when I get to this red one, when I have a multiplicity of 2, I'm going to make it bounce. So I'm gonna go up through this one, make it bounce through this one, and then make it come back down through the green one. So that's negative, negative. And then the last thing I need to do is a y-intercept. And the y-intercept is when this is in standard form, I'm gonna look at the last number. So like down here, my y-intercept would be this -36. And that came from multiplying all the last numbers. The 1, the 4, the 3, and the 3. So I'm gonna multiply all those for up here. I'm gonna erase these so that way we can see what numbers I'm multiplying. So I'm gonna multiply -2 times -3 times 3 times 1, and remember there's a second one of these, times the other one. So -2 times -3 times 3 times 1 times 1, and when I put that all in my calculator, I get 18. So then this y-intercept is 18. And then I'm done. I've named all the x-intercepts. Oh, y equals 18. Right, so there's all my x-intercepts, there's my y-intercept, and then 7 as I sketched the graph, which I did right there. Right, so then question 11 down here, remember when we did the exponents, the 3 becomes the outside number of the house. And then the 64 stays in the house with the 4 as the exponent. The 4 on the outside could be under the house or it could be outside the house. So that's why this one's good, because it has a 3 as the index and the 4 is outside. This one is not good. This is the reverse. So we're not doing that one. 3 to the 4th. That's not going to work because when we do, if we break this down, we could do the cube root of 64. We would check our calculators and we would get 4. And then the 4 to the 4th root is not the same as 3 to the 4th. That's done. This one has the same thing, and it's okay if the 4 is under the house or if the 4 is outside the parentheses, that means the same thing. And then 256, this would be 64 to the 4th. There's no way that 64 times 64 times 64 times 64 would be as small as 256. So that's not an answer either. Then question number 12, this is the one that was just on our last quiz. We're going to square root both sides. We need to get rid of the square to solve for x. So I get x minus 4 equals the square root of -49 is plus or minus. The negative switches out to become an I, and the square root of 49 is 7. And then I just have to solve it by adding 4 on both sides. Remember, we like to squeeze it in here so that way it stays in the right format. And there is our final 2 answers, 4 plus 7i and 4 minus 7i. All right, question 13 has kind of 3 questions in it, and we're adding, subtracting, and multiplying these 3 together. So when we're adding, we just keep the real numbers together. So 6 plus -4, which equals 2. And then -3i plus 6i is 3i. So then we just put those 2 together. 2 plus 3i. All right, now we're subtracting over here, so it's going to be 6 minus -4. Which when we have minus and negative, that really means plus. So this is going to give me 10. And then I'm going to have -3i minus 6i. -3i minus 6i would be -9i. And then that's the last part of our problem. -9i. All right, and then when we're multiplying, this is when we need to do our box. So we have 6 minus 3i, -4 plus 6i. I'm going to multiply, so -24, 36i, 12i, and -18i squared. Remember, I equals I squared equals -1. So this is really -18 times -1, which gives me a positive 18. So now this is a real number and this is a real number, which gives me -6. And then these two are imaginary numbers. So I add those together and I get 48i. And that's my final answer. All right, number 14 is very similar to number 12 that we just did, because the only thing is that we need to move this 8 first before we can square the side. So I'm going to move 8 over here, and it's 4x plus 3 equals -9, and it says, why does it have no real solution? And that's because the square root can't equal a negative number without using imaginary numbers. So a square root can't equal a negative real number. It's imaginary. All right. The rest of them are going to be on the next video.